Okay.
That was the scariest day of my entire life.
All right.
I can't even tell you that. You're looking at my window stairs. Oh my god, that one day, man.
There we go.
It's like a party.
It's like a
Party wizard hat. All right, here we go. Now, what does gamma look like?
It's
What is that?
it's a
Wave.
Wave.
Wave. It's a wave, right? Okay, so it's a wave. All right. What's beta look like?
it's a little tiny
Tiny particles. Put a little dot. What's positron look like?
Man, you should have left it up to me, man.
I don't know what that looks like, but alpha's like
It's the same thing as beta, just
big
opposite
old
charge.
It's a
Now, what
big
about
old-
alpha?
She's a big old one.
It's a bigger particle, right? So we'll just make a bigger circle there, fill it in. All right, now, Trevor is standing behind the concrete wall, and there is dangerous radiation being shot at him. Now, the wall is concrete and a meter thick. That's pretty thick. Concrete's pretty dense. However, only high density concrete or lead will prevent him from being completely blasted by radiation. Since that is not high density concrete, it is not lead, some of this radiation will get through.
I'm here to tell you
Which
what it is.
particles or wave, which ones will get through, which ones will not? Which one do we know for sure will not get through?
Alpha.
Alpha for sure.
Yeah.
Alpha's going to hit the wall and it's going to stop right there. Okay? Alpha's going to hit the wall. If you would like to show it falling to the ground, that would be fun too. But it doesn't really do that. It absorbs actually. Who's ever gotten an X-ray? Besides Will. Okay, I've had a lot myself. So yeah, what do they put on your body?
A lead blanket.
Yeah, lead vest, lead something, lead blanket, except for the area they're taking an X-ray. Why?
Because they need to see the bones in there.
No, why do they put the lead?
Oh, protect you.
Right, protect you, right? So lead in high density, so stay with me. I know we're, kind of being silly here, but lead in high density concrete, which is different than regular concrete, and I will admit, I don't know how they make it different, but it is. So high density concrete and lead will block all forms of radiation, all right? That's why they put lead on you when you get x-rays. We've talked about this before, right? Because my issue with the dentist.
What?
No.
You ever get x-rays at the dentist?
Yeah.
Where they put that thing,
So what's
and then
the
they go
issue?
around the other room, and they're not there, and they hit the
You're
button, it
like
goes,
just-
eh.
Your teeth
Right.
are just biting around.
Right, you're biting
just
on that thing, you start drooling,
They
right?
started choking you.
Is that just me?
Yeah.
So,
And
you
you're
got this
obviously
pointing
sick.
at your face. They put the lead vest here to protect your organs and everything.
Your brain is right here. Though.
Right! They should give you a lead helmet. I'm serious.
And then I'm gonna walk over
Right?
against the window.
Who has sat there and been like, what about my head?
The brain.
Nobody?
Yeah.
Just me.
I hope.
I'm like, my brain's like
I
literally
don't
right
think
there.
about that. I'm just like, I'm awkwardly staring.
Anyways,
Yeah.
it's a fairly relevant
Old lady
point.
have her
Back to
fingers
this.
right now.
Alright. Positron and beta will actually go in, but not too far. They'll get stopped some point, maybe a few centimeters actually, into the wall. They will penetrate a little bit. Foil,
Penetration.
metal does a good job protecting from beta and positron, and depends on the thickness. Again, a lot of books, things will say foil, but aluminum foil, for example, is too thin. You need thicker. And unfortunately for Trevor, gamma will go through and hit him right in the face. So the gamma can only be stopped if we were to put something between him like PB. That's lead. Then lead would stop Trevor's face from being irradiated. So the concept, again, I'm kind of screwing around here with Trevor and drawing pictures, but what you need to know for the class and the regions is gamma has the highest penetrating power, alpha has the lowest. All right, and again, lead, high density concrete can stop gamma, and again, the thickness. So if we had regular concrete that was like, 10 feet thick, it probably would stop gamma radiation. In fact, nuclear power plants, their reactor core is surrounded, I think, by 3 meters of concrete. I'm not sure if it's high density, but that's 3 meters thick. That's a lot of concrete. So that's why, or that's pretty effective at absorbing and blocking radiation. So, so you do need to know the order of these things. Why would gamma be the best at penetrating?
Because it's not like physically like.
It's a wave. It's energy, right? Why would alpha be the worst? It's a big part of it, right? Okay, so it won't fit through things. Good. All right, lights, please. Now you're going to draw another picture. I'd say at least half a page.
What?
Oh, I am ready.
That's so good.
He drew you.
He drew you.
I'm just gonna use whatever.
It's actually a good drawing. Really funny.
Is the wall like way bigger than me?
That
But that would have been funny.
funny.
Yeah, that would have been funny.
Oh, there. Oh, there it is. Okay, yeah, got it.
That's usually the first go-to thing kids do.
Now
Alright,
you're on a stool.
here we go. Now I'm on a stool.
Yeah.
That's funny.
But the camera is going straight through your brain.
It's
Where's my lead helmet?
funny. Listen, when I invent that and I sell it at the dentist's office, somebody's gonna get rich.
He's gonna be the only guy calling his wife in the dentist's office. Honey, I forgot the lead helmet.
That's a good, but isn't it worth it?
No.
Yes. Plus, you lay back. It's not like
No, what about the ones where you're like
You
standing
know
up
what
and you have your
I'm
teeth
for,
around
man.
the
Usually you're sitting.
Radiation.
Thing. Usually you're sitting, but sometimes, oh, you do sometimes have to stand. Yes.
Yeah.
That can't have a good thing on it.
The dentist?
Come on, say it like you used to say.
The dentist?
No, you say it like dentist.
Yeah, you're like
The
dentist.
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 Do you have a dentist named Dennis? Yeah.
No, the dentist.
Is that what you call him, the dentist?
Sometimes. You guys ever see the Rudolph animation?
Yeah.
With the guy with the snowman looks like Mr. Bentley?
Yeah.
Yeah. So the elf, I really enjoy how he's like, I want to be a dentist. I really enjoy how he says that.
I really hate that. I really enjoy it.
Alright, moving on. I don't know what the best part is. Probably the snowman.
Is this a song?
Alright, no.
Ever.
Did that just occur to you when I said that?
Yeah. It just occurred to me.
So funny. Alright,
The abominable snow.
here we go.
Ernest Rutherford was one of the first to show that radioactivity could consist
I'll tell you what
of
to
three
draw in a second.
distinct types of radiation. The three types differ in their response to an electric field. A source of radioactivity is passed through a hole.
You're essentially going to draw this. It doesn't have to be perfect. Alright, maybe I'll just sketch what you should draw. So, you have some sort of radioactive source.
And
You
then
have a screen down here that's going to collect that radiation. This you do not need to put in. Don't put that thing. And you're going to have a beam of radiation. Just draw a straight line with an arrow. So that beam right now has three forms of radiation. It has alpha, beta, and gamma. They spelled gamma wrong. So
Good
alpha,
job.
beta, and gamma all contained in this beam. I'm actually going to turn it off because I don't really need her. If we keep playing this, they're going to bring in an electric field. The negative part of the field is down here. The positive part is up on top there. Watch what happens to the beam when they introduce an electric field. Right now she's just talking about everything that we already know. Okay, good. So now what I want you to write down is show the different spots that it hits the screen. So here's the one in the middle. Draw one going up, and then draw one going down, and notice how this one going down isn't as far from the center. It's a little bit closer than the one going up. So draw that the same way if you can. And then here we got a plus, here we got a minus, right? Yeah. So the video is good for visual, but I really want you to sketch the picture in your notes. This exact diagram has been on the Regents before. It's a really easy concept. I think some of you probably already know where we're going with it. So you have three forms of radiation, alpha, beta, gamma, without an electric current, positive, negative, which is like kind of like magnets, sort of, right? Electricity and magnets both have poles. So without it, it's a straight beam, they're all mixed. But when you start putting a charge associated to it, they split. They separate, well these two do, and the other one goes straight through. So right now, in your head, think about it. Don't say it out loud.
Wait, what are the three?
Don't say it out loud. Gamma, beta, and alpha, or alpha, beta, gamma. You should be able to tell me, we'll number these. 1, number 2, number 3. Which one is the beta, which one's the alpha, which one's the gamma, based on the electric field. So I'm going to give you 30 seconds to think about it.
I forgot the question.
So did I.
Okay, number 1, number 2, number 3, your job is write in your head. Don't write it, because I'm going to give you the answer. I don't want you to screw up your notes
I
there.
have pencil.
Number 1, number 2, number 3. which one is alpha, which one's beta, which one's gamma. Based on how the radiation is affected by the charge, positive and negative, you should be able to figure out which one is which.
Oh, God.
Which one's alpha, which one's beta, which one's gamma.
Got it.
And for fun, top right corner of your notebook, put the number that is gamma. So I can come around and check. Write the number that's gamma. Top right corner of your notebook.
Oh, crap, that's the left.
No, your top right.
Hey, good job.
Oh,
Right or
oh, that's
left?
fine.
Way to follow instructions, Amanda. I don't care.
Oh,
Yo.
What's your number?
Say, hey, good job.
1, 2, or 3. Right? There's only 3 of them. 1, 2, 3. Which one's gamma? Please hold. Trevor, can I see the drawing?
Ain't don't snap.
I can't snap. I'm being so excited. I am. I was upset.
You even got your earring in there.
That's usually the big
I
thing.
can't. It's this one for that one.
Who has period 8 lab in here? A bunch of you guys, right? So I used Tyler as an example in period 2, and then I had a bubble coming from his mouth. Guess what it said?
Hi, I'm Tyler.
Hi, I'm Tyler. That was funny.
Wow, that's really clever.
It was very funny.
That's the only thing he says.
It was, listen, you gotta be there
That's really
to
funny.
understand.
Listen, I've heard him say hi,
All right.
I'm Tyler about 10,000 times.
Now, number 2, everybody got right. Gamma. Very good. This is gamma. Why is that gamma? No charge. Very good. 0 over 0. I don't know if you guys can see this because of the screen, but it's 0 over 0 with the weird little symbol there. All right, raise your hand, please. Not out loud. Raise your hand. Number 1. On.
Alpha. No? Is it wrong?
Yep.
I said beta.
How is that wrong?
It is beta.
Because beta is negative and negative goes towards the
Opposites attract.
Yeah.
Just think of it that way.
There we go.
Woo!
Yep. I
All
was
right.
talking about the positive sign.
Very good. I'm glad we figured that out. So beta goes up. Now, listen to how the Regents words it because it's weird, right? Listen. It will say, which of the following particles are deflected towards a positive field?
That's easy.
So they say deflected towards. Kids don't like that because what does deflected mean?
Bouncing off.
Deflected means kind of get away, right? They say deflected towards. To me, that's kind of like an oxymoron. But deflected towards, they mean go towards. Go towards a positive, that's negative, which is beta. So who's 3? Alpha, good. Now, who's it going to be? You know who I want to call on?
Trevor.
Morgan.
Morgan.
Why?
I knew
I knew it also. I don't
All right, I'll give you a break today. Amber.
No.
Now,
No.
why?
Amber, too.
What?
Yeah, it's true. It's like
Yeah, it's
Trevor,
always
Morgan.
me.
Just deal with
And I
the
always
people.
go,
Playing safe, you call on everybody. That's what good, Bob.
Stone.
Autumn, I need you.
Kristen always gets called on a lot.
All right, enough. Amber, give it a shot. Why is alpha closer to gamma than beta? And it,
Science.
all right.
Nice.
Oh, I thought you said draw them evenly.
I don't know.
They're not like that.
No, they're not even. Look, so this one is closer than that one is to the center
Yes.
point.
Okay.
Do you want to help her?
Yes.
All right, go ahead.
I mean, I don't know if I'm right, but maybe because it's bigger, it takes more energy to pull it down.
Very good. Good job.
Thanks, Mom.
Because alpha has a larger mass, so if you're trying to push someone who is very light, you could probably push them very easily. But if someone's very large and heavy, it's hard to move them. What?
Give us an example.
I know, you told me.
Me and Mr. Decker.
Oh, yeah.
Okay.
Tell us all about
Well, so for example, Mr. Vogel, very strong man, could throw me across the room. What is that? What is it? What is that?
Like so accurate.
Just stop that.
That's what he does.
Stop
So
that.
accurate.
Now, the analogy is Mr. Vogel could probably throw me across the room. Pretty strong dude. I don't weigh a lot. But Mr. Decker and Mr. Vogel are closer in size. He would have a harder time moving him. That's the analogy. So the same thing. Stay with me. Stay with me. Don't twist that. Okay. I'm good friends with Mr. Decker. He's bigger than me. I'm smaller than him. So the concept here is small particles can be deflected very easily. They don't have a lot of mass. The more massive particles, it takes more energy. So that was very good, Willow. It's deflected, but not as far. Good job. All right, lights, please. We're done with this.
No, keep the lights on.
I don't understand why teachers always want like all the lights on.
Yeah.
And especially teachers who want to conserve energy and be good to the planet.
Oh! Oh God.
Write this down, please.
Are these-
Artificial.
Are these new notes?
I don't know how to answer that question.
What do you mean?
I really don't.
Are they continuing or are they new?
These notes have nothing to do with what we just
It's a
talked
part
about.
of nuclear chemistry.
But it is part of nuclear chemistry.
So it's continuing.
So continuing. Okay.
They're strong.
Artificial and natural. Now I can only say this so many times, but I'm going to say it 3 more times here. Going to table N. So table N. That is natural. Okay. That is natural. You need to remember that. I'm going to write 3 examples. You're going to do the or show the decay equation for all 3 examples again. So if you are not good at this by the end of today, then I think there's an issue. Here we go. Let's go with Fe53. So Fe53, arrow. Look it up. Do the decay equation, please. Let's go with P32. P32. And then one more. We'll go with Ra226. Ra226. So show me the decay equation for all 3 of those, please. And again, these are examples of natural transmutation. I will go through these very quickly, and then I will talk about fission and fusion, which are artificial. So the first step, remember, is always look up the decay mode, write down that particle, then do the math, see who it turns into. Or I should use the word transmutate into. Caroline, you with me on this? Okay. So I told period 2 a little trick. I think table N stands for natural. Try and remember that.
Oh, wow.
That's all natural decay on it.
That's so clever.
Thanks.
You're welcome.
So I know some of you probably aren't done. I'm going to speed this up a little bit.
I'm done.
Alexis, what type of particle does Fe53 release or emit? Positron, very good. So Fe53 is positron. That's 0 plus 1 E. All right, what about P32, Kieran?
P32, it goes into 0, -1 E, and then
Beta.
30.
Oh, stop. That's it.
Okay.
And Adriana, radium?
4/2 Ag.
Right, alpha. So next to these, if you have room, if not, put it to the right, where I'm sure you have room on one side or the other. This is called beta. No, it's not. Sorry. First one's called positron decay. I'm just trying to give you the phrases as much as possible because when you get to the regents, I don't want you reading a nuclear question and being confused with the wording. Because you know what to do, I just don't want you to be confused with how they might word it. So they say natural decay, spontaneous decay, or they'll give you the actual name, positron decay, meaning it gives off a positron. This is called beta decay. Beta decay, and then the last one is alpha decay. All right. Now we just have to show what they transmutate into. What's up, guys?
I gotta show you this.
Like right now in the middle of class.
Yes.
You have to interrupt class.
Yes, sir, yes.
This better be worth it.
It's Dylan?
You did that on the computer?
Yeah. It's so sweet. It's Dylan.
Oh, that's Dylan.
Adam goes, you remember yesterday? I
Oh
was like,
yeah.
That's
funny. That is very
Why
that's
do
funny.
you say that's funny, but you don't ever laugh?
That's funny. All right. Where did he go?
Dylan, I don't know.
Dylan. Takes a lot of courage.
Yeah, thank you.
Yeah, you're welcome.
What
Back-
a chair.
Back to this. Now, what does this transmutate into?
Oh, I got that.
Who's got it? I know he does, Amanda.
Oh, wait.
Okay,
Yes, I do. I just sort of
53
plus sign
Yep.
confused me.
over 25.
Yep.
And
Amen. Very good, because this is 26. Good job. Okay, who's got this one here? Karen?
We're on P.
Yep.
Yeah, okay. 32 over 16x.
Good. And radium, you got 88 on the bottom. Sorry, I got messy there. What's the other one there? Who have I not talked to today here? Olivia, have I called you yet?
No.
Okay.
222 over 86 are.
Very good. All right, so I hope you guys are good with that. I just wanted to get some examples in our notes of alpha, beta, and positron. We did a bunch of practice problems, but this is like official continuing notes, or whatever you want to call it. All right, so that's natural. Let's talk about artificial quickly before the bell here. You do not have homework again. That's unbelievable, but you don't.
Yay. Thank you.
Don't worry, you'll have some due Friday.
And it'll be a whole packet.
Nah, just a worksheet. All right, here we go.
A bunch of them sit.
Nuclear fission. What is it? Andrew, I didn't talk to you yet today. What's fission? What's fusion? Give me one or the other. Do you remember? Fusion is combining. Fission? Take apart. Very good. So, let's talk about fission first. Where does fission occur? Where does it occur? If it's artificial?
In a lab.
In a lab. Very good. Where does fusion occur?
Sun.
On the sun, except in chemistry it's weird. Because yes, it's natural on the sun, but on Earth, fusion cannot occur naturally. We have to do it in a lab. So we still say fusion is artificial, but it does occur on the sun. We'll talk more about that tomorrow. Fission, there's two elements that can do fission, U-235 and then Pu-239. So those two elements can undergo what's called nuclear fission, which creates a lot of heat and energy. So U is 92, Pu is 94. Here's how fission works. Take a big nucleus, take a little tiny neutron, slam it into the nucleus, and the nucleus will split into two smaller nuclei. And then it will release more neutrons, and those neutrons go on and hit more uranium, and it keeps splitting and splitting and splitting. What's that called when one thing happens and then something else happens? Chain reaction. Very good. This is called a nuclear chain reaction. Some people say domino effect, same concept. So you take a neutron, slam it into the nucleus of uranium, it splits into, having a moment right now, barium and krypton. Sorry, couldn't remember. Barium and krypton. Same thing for plutonium, you hit it with a neutron, except I think it's strontium and krypton. Hold for 1 second. Yeah, strontium and actually barium and strontium. All right, we'll do this again tomorrow. We'll pick up with that tomorrow. No homework.
Enjoy.
Enjoy the rest of your day.
Oh
Good
my
luck
God.
today for those of you who have a game.